Hi everyone, this is Dr. T. Siva Nageswara Rao, working as Assistant Professor of Mathematics in the Department of Mathematics and Management Science, VJYEC. In previous lecture, I explained about how to find eigenvalues and eigenvectors for the given square matrix. Just one more time, I will recap the previous topic. In previous topic, we discussed about how to write the characteristic matrix denoted by A minus lambda I, how to find the determinant of the characteristic matrix, we will get the characteristic polynomial. By equating characteristic polynomial to 0, you will get the characteristic equation. From the characteristic equation, we will get the characteristic roots. We will call these characteristic roots as eigenvalues or proper values. In previous lecture, I given one example how to find eigenvalues and eigenvectors of the given matrix if the roots are distinct. Today I am going to discuss about one more example. For a given square matrix of order 3 by 3, we will get 3 eigenvalues. Out of 3 eigenvalues, assume that 2 eigenvalues are repeated and 1 is distinct. How to find its corresponding eigenvector? Now, this is the example. Find the characteristic roots of the matrix capital A and corresponding eigenvectors. What is capital A? 3 by 3 matrix 2 1 1 1 2 1 0 0 1. Likewise, in previous class, first we will write the characteristic equation, that is determinant of the characteristic matrix equal to 0. That is determinant A minus lambda I is equal to 0 implies determinant 2 minus lambda 1 1 1 2 minus lambda 1 0 0 1 minus lambda equal to 0. We will get the characteristic equation as minus lambda cube plus 5 lambda square minus 7 lambda plus 3 is equal to 0. Corresponding to this, the characteristic equation, the eigenvalues are lambda 1 is equal to 3, lambda 2 is equal to 1, lambda 3 is equal to 1. If you are observing this, out of 3 eigenvalues, only 1 is distinct and remaining 2 are equal. In such cases, how to find the eigenvectors corresponding to these eigenvalues? Now first, I am going to find corresponding to lambda 1 is equal to 3 the eigenvector. Now how to write the eigenvector? What is the definition of eigenvector? Earlier we discussed. If lambda is any eigenvalue of capital A, then there exists a non-zero vector capital X such that Ax is equal to lambda x. Here I will write A into x1 is equal to lambda 1 into x1. I will write this as A minus lambda 1 multiplied by I multiplied with x1 is equal to 0. Now I am going to write A minus lambda 1 I. That is 2 minus lambda 1 1 1 1 2 minus lambda 1 1 0 0 1 minus lambda 1 multiplied by the column vector x1 contains 3 elements x1 x2 x3 on right hand side 0 matrix, column 0 matrix. Now substitute here. In place of lambda 1 with 3, we will get 1 1 1 1 minus 1 1 1 1 minus 1 1 0, 0, minus 2 multiplied with x1, x2, x3. This is equal to the column matrix 0, 0, 0. Now here our aim is to convert this coefficient matrix into echelon form by applying row transformations. That is R2 goes to R2 plus R1. Hence the resultant matrix is minus 1, 1, 1, 0, 0, 2, 0, 0, minus 2, x1, x2, x3. Here the third row is again, we want to make it as 0 by using one more row transformation, that is R3 goes to R3 plus R2. Therefore the resultant matrix is minus 1, 1, 1, 0, 0, 2, 0, 0, 0 multiplied with x1, x2, x3 is equal to 0 matrix. Clearly the rank of this matrix is 2, number of unknowns is 3, therefore we will introduce only one arbitrary constant. By introducing only one arbitrary constant, you will get the characteristic vector or our eigenvector as 0, 0, k, where k is not equal to 0. This is how we can calculate the eigenvector corresponding to distinct eigenvalue. Next we will see how to find the eigenvector corresponding to repeated eigenvalue. Lambda 2 is equal to lambda 3 is equal to 1. Now directly I will write there the matrix A minus lambda 3i multiplied with x3 is equal to the column vector 0, 0, 0. That is 2 minus 1, 1, 1, 1, 2 minus 1, 1, 0, 0, 1 minus 1, 1 minus 1. Here lambda 3 is 1 multiplied by x1, x2, x3 column vector. It is denoted by either x2 or x3. On right hand side column vector 0, 0, 0. Now 2 minus 1, first row 1, 1, 1, 1, 1, 1, 0, 0, 0 multiplied with x1, x2, x3 is equal to 0, 0, 0. R2 goes to R2 minus R1. Hence the resultant matrix is 1, 1, 1, 0, 0, 0, 0, 0, 0. That is x1, x2, x3. On right hand side 0 column matrix. If you are observing this matrix, clearly the rank is 1 but number of unknowns are 3. Therefore n minus r is equal to 3 minus 1 is equal to 2. We will introduce two arbitrary constants. From this matrix system I am going to write system of equations x1 plus x2 plus x3 is equal to 0. I am going to assign x3 is equal to k1 and x1 is equal to k2. x3 is equal to k1 and x1 is equal to k x2. x2 is equal to k2. Then what is x1 value? We can write minus x2 plus x3. Therefore this capital X becomes the column vector x1, x2, x3 this is equal to x1 minus of, here I am going to replace in place of x2 with k2 and x3 with k1. So this becomes k2 plus k1. What is x2 value? We are taking k2. What is x1 value? k1. Now I will write this as sum of two vectors like k1 multiplied by minus 1 0 1 plus k2 multiplied by minus 1 1 0. This is how, if the eigenvalues are equal, we will rewrite the resultant eigenvector as linear combination of two vectors. This one of the eigenvector we will take it as x2 and other one as x3. So this is how we can find out the eigenvectors corresponding to the given matrix if two eigenvalues are repeated and one is distinct. Assume that throughout the unit we will take at most the matrix order is 3 by 3. Here I am providing few examples, that is worksheet problems. Please solve it, in which I introduced a matrix with distinct eigenvalues and a matrix with repeated eigenvalues. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.